Welcome to Discrete Math. This is Lecture 7, Rules of Inference, Part 2. So today we're going to talk about the rules of inference in predicate logic. Okay, so there's a few that are specific to predicate logic. The ones from Rules of Inference, Part 1 also carry over to predicate logic, the ones from propositional logic, but these ones are going to be specific to our quantifiers, the universal and existential quantifiers. Okay, so to start off, we've got the universal instantiation. And this is saying, well, if we've got the statement for all x, p of x, so all x have this property p of x, we can instantiate this, we can conclude that this property holds for some c as well. Now to look at it as an example, we've got the statement all humans have DNA, therefore Socrates has DNA. Okay, so you can instantiate this for any arbitrary C. You can just say there's someone who has DNA. You can instantiate this for a specific person like Socrates, anybody who's within this domain of all humans or all animals or all beings, whatever it is. Okay, so that's universal instantiation. Next, you've got what's called universal generalization. This is going the other way. This is going from a specific instance to a general claim for all x within your domain. Okay, so we have some property p of c for some arbitrary c, and then we could go ahead and generalize this, and we conclude that this property holds for all x. Okay, so an example of this might be something more mathematical. This is a much more difficult direction to go in, that we just have a few data points or a single sample point, and we try to make a generalized universal claim from it. This is much more common in mathematics or numerical claims. So if we can show that, for example, an arbitrary triangle has interior angles that sum up to 180 degrees, then we can generalize that for all triangles have interior angles summing to 180 degrees. And note, this is going to be really important that we do this for something arbitrary. So this is something non-specific. In other words, any triangle could have met this criteria. And that's part of what allows us to generalize this to all triangles, because of the fact that that arbitrary triangle could have been anything. Okay? So that's universal generalization. Okay. Next, we've got existential instantiation. So we have a claim: there exists some x such that x meets this property or has this quality p. Okay. We simply instantiate that to some arbitrary c. Okay. This is a singular element c within this domain x. So remember, this is also saying there exists at least one x. This could mean one, two, many x's. It's not specific even numerically. So when we're saying instantiation, we're saying, well, let's just say that there's at least one. There's someone or something that meets this criteria p. Okay. So as an example, there exists at least one person who is a doctor. We can instantiate this by saying, let's call them C, and say that this person C is a doctor. Okay, and the benefit of this is that it allows us to at least work without quantifiers and refer to some specific consistent element C as we're doing this. Okay. And the last one is just going the other way. This is existential generalization. If we know that there is some p of c, some element c possesses this property p, well, then we can just make that general. We can start making that a non-specific claim where we can say there exists at least one x such that p of x, that x being c. Okay, so we could say something like, well, Socrates got an A in the class. Now, let's suppose you want to kind of anonymize that claim, make it more general. You can say, well, therefore, someone got an A in the class. We don't need to refer to who that is, or we don't even need to specify how many people that is, right? Because this is just saying at least one, and we know for a fact that there is one. Okay? So those are our rules of inference for predicate logic. Let's see some examples of how these are applied. So when we started our discussion of predicate logic, we started off with this example. Suppose we have this premise, all humans are mortal. Socrates is a human. Does it follow that Socrates, therefore, is mortal? And we said that this is where propositional logic failed us. We weren't able to navigate this difference in subjects from this general claim to the specific claim. And that's why we needed predicate logic. Okay, so now we can make use of these rules of inference within predicate logic to transition from this general claim to the specific claim and apply this general property of mortality to someone specific like Socrates. So let's see how that works out. So let's suppose h of x, this propositional function, refers to x is a human. We'll say m of x means x is a mortal, or x is mortal. Okay. So our argument, our first premise, we can translate all humans are mortal as a conditional statement by saying that such for all x, it is the case that if x is a human, then x is mortal. Okay, so this is our starting premise. Our second premise, we're told that the specific person Socrates is a human. Okay, so within our propositional function, instead of x, we can just throw in Socrates. So h of Socrates, Socrates meets this criteria. Now, what we can do using our newly founded rules of inference, we can use universal instantiation on line 1 and instantiate this, go from this general claim about x to a specific claim about our subjective question, Socrates. So we can say, well, if Socrates is a human, then Socrates is mortal. Then we already know from premise 2 that Socrates is a human. So finally, we can just use modus ponens on 2 and 3 and conclude that Socrates must be mortal. Okay, so let's look at one more example about how we might use these rules of inference for predicate logic. So example B says, some student in this class has not read the book. That's our first premise. The second premise says, every student in this class passed the exam. We want to show that some student who has passed the class, or sorry, passed the exam, has not read the book. Okay, so let's let C of x mean x is in this class, B of x mean x has read the book, and P of x mean x has passed the exam. Okay, so now let's first of all just translate these premises and our conclusion that we're trying to get into terms of these propositional functions. So let's see how that looks. Well, our first premise, there is some x where x is a student in this class, right? So this x meets this criteria that they are in the class, and they have not read the book. Okay, so that's negation of B of X. Our second premise, every student in the class, so for all X, if X is a student in the class, then X has passed the exam. Okay, so X by itself doesn't necessarily mean that X is a student in the class. We need to specify that using C of X. X could be the domain of all students. It could be people, human beings, something like that. Okay. So that second one is going to become a conditional. Okay. So from this, let's go ahead and use existential instantiation on line 1. Okay, so all we knew is that there was some student, at least one student, for which these two conditions were true. Okay, well, let's call that student S. It's just a student, some arbitrary student. We don't have enough information that we can generalize or we can instantiate this sort of universal claim into a specific person like we could before. So we're just going to say that this is some person S, some consistent value that we can refer to again and again. Okay. So we've got C of S conjunction, not B of S. Well, if we use simplification, we can break this conjunction apart. So we can pull out the C of S by simplification on 3. Now, let's use universal instantiation on line 2. So we had this conditional statement for all X, if C of X, then P of X. Well, let's go ahead and instantiate this for our specific person S that we're talking about. The same one that we instantiated in line 3. Great. So now I already have the antecedent for that conditional. Okay, so we can potentially use modus ponens. And that's exactly what we're going to do in our next line. We use modus ponens with 4 and 5, and this allows us to conclude P of S, that this person S has passed the exam. Okay. If we again use simplification on line 3, we can pull out the other part of that conjunction, the other half, and this says not B of S. So it is not the case that S has read the book. We can put together the information from lines 6 and 7 using a conjunction. And we've got P of S and not B of S. Now, our original goal was to show that some student who has passed the exam has not read the book, right? So we want to show that some person meets both of these criteria. And we've technically done that already. We've shown that this person S meets both these criteria. But we want to make this not just for this specific person S, we want to make a more vague claim, a more general claim about just some person, anonymized claim. So we can use existential generalization to replace that S with X, and we can say, well, there is some person X who has passed this exam and has not read the book. Okay, so this was just a quick look at how we can apply the rules of inference for predicate logic, and this is going to be just a quick wrap up for the logic portion of this course. All right. So I hope that made sense. Thank you for watching. Please remember to like the video and subscribe to the channel if you found this helpful so that you can see more content in the future.